This is our review for the upcoming unit test in Algebra 2. So one thing to really keep in mind is we've already been quizzed on this. So you had a review 1.5. Go back and look at that review. Look at the quiz that you had because we've only covered, I think, 3 lessons since the quiz. So a lot of material from the quiz will be on the test. Okay, and then these are all the different things that you've seen in this particular section. But like I said, don't just look at this one review. Look at the review 1.5, the quiz that you've received, and we'll go from there. So let's take a look. Exponents and radicals. Simplifying expressions, that means that everything under the radical needs to be in simplest form. Nothing can be condensed, and there are no negative exponents. So I'm taking cube roots here. So let's bring everything together. So when they're multiplied, it's a good strategy to do that. So this is, what, 24x cubed when I multiply the 2x and the 12x squared. So this is the cube root of 3 times 8 times x cubed. So now I notice immediately this is a perfect cubed. So if I bring that out, so the cube root of 8 is 2. The cube root of x cubed is x, and what is left underneath that cube root radical is the cube root of 3. Number 2, 7 to the 1/5 times 5 to the 1/5, all to the negative fifth. Okay? If I just distribute this negative 5, I'm going to get 7 to the 1/5 times negative 5. And then I get times 5 to the 1/5 times negative 5. So 1/5 times negative 5, that's negative 1. So this is 7 to the negative 1 times 5 to the negative 1, which is 1 over 7 to the 1 times 1 over 5 to the 1. That is 1 over 7 times 5. That is 1 over 35. Okay? Number 3, simplifying a cube root radical. So I want perfect cubes. So this is the cube root of negative 1 times 27. And then m cubed, m cubed m. That's how I write m to the 7th. N cubed, n squared, p. Now my perfect cubes are all of these, okay? So the cube root of negative 1 is negative 1. Cube root of 27 is 3. The cube root of m cubed is m, and I have 2 of those. The cube root of n cubed is n, and then I'm left with the cube root of m, n squared p. And that is my answer. Minus 3 m squared n and the cube root of mn squared p. Number 4, your teacher is trying to trick you with negative exponents to see if you can handle all of that. If I look at this top of the fraction that's raised to the negative 2, well, if I move that to the bottom of the fraction, that becomes a positive exponent. Similarly, if I look at the denominator, if I bring that up to the top of the fraction, that's where I get the x cubed. Now let's just distribute everything out and simplify. This is x cubed over 2 squared is 4, x squared y to the 4th. And now I can simplify. This is x to the 3 minus 2, 4 y to the 4th. So this is x over 4y to the 4th. Number 5, I've got lots of exponents and 4th roots that I need to deal with. So this is the 4th root of, the top is 16. I can write that as x to the 4th, x to the 4th, x to the 4th, x to the 4th. Okay. On the bottom, I've got the 4th root of 81. And rather than write this out however many times, well, I guess it's going to be 6 times. Um, it's really just, I'll go ahead and write it out. Y to the 4th, so that is 12. So 1, 2, 3, 4, that's 16. Do I want to write all those out? I maybe don't want to do that. Let me just write it this way. Let me back up. It's just too much writing for me. I can write this as y to the 4th to the 16th power. That's y to the 64th, okay? So now, if I look at everything in terms of simplifying square roots, 4th root of 16 is 2. 4th root of x to the 4th is x, and I have 4 of those, okay? 4th root of 81 is 3, okay? The 4th root of y to the 4th is y, and I have 16 of those, okay? So 2x to the 4th over 3y to the 16th power. So I could have written y to the 4th. I could have written it down 16 times and gotten that. That just would have been a little bit too much writing. Number 6. So what's in the parentheses is being raised to the -2 power. Let's move all of that to the denominator, and we raise that to the 2nd power. So this is 3x over x to the 4th, y to the -4th. So this is 3, and then I have x to the 1 minus 4, and y to the 4th. So I'm using the quotient property of exponents. So this is 3x to the minus 3, y to the 4th. That is 3y to the 4th over x cubed, okay? You just need to keep straight all the properties of exponents, handling negative exponents, and how you combine quotients with exponents. Number 7, an expression raised to the -2 power. That's the same as 7x over 2x squared. Well, let's make this easier. X over x, that's 1. This is 7 halves squared. This is 49 over 4. Number 8, it looks complicated, but everything you see on the top of that fraction raised to the 0 power, that's 1. So this is 1 over 2 x to the -2y. So this is x squared over 2y. Number 9, combining radical expressions, adding and subtracting. I can only do that if everything is the same. So let's look at 4th root of 32. So 32 I know is divisible by 2. You probably know this already. If you don't, you can always just divide it out. That's 2 to the 5th, okay? That's 32. And if I look at 48, when I divide that by 2, I get 24. Divide by 2, I get 12, 6, and 3. So this is 2 to the 4th times 3, okay? So what I have here is 2 times the 4th root of 2 to the 5th minus 3 times the 4th root of 2 plus the 4th root of 2 to the 4th times 3. So this is 2 times the 4th root. I'm going to write 2 to the 5th as 2 to the 4th times 2 minus 3 4th root of 2 plus 4, plus the 4th root of 2 to the 4th times 3. The 4th root of 2 to the 4th is 2. So this is 2 times 2, 4th root of 2, minus 3, 4th root of 2. The 4th root of 2 to the 4th is 2, so this is plus 2, 4th root of 3. So this is the first one. This is a 4 minus 3. So 4 minus 3, 4th root of 2. So this final answer is just going to be 4th root of 2 plus 2 fourth root of 3. Note those two terms will not combine. X to the 3 halves to the minus 3 fourths times x to the 5 fourths. Why don't I just go ahead and multiply all of this out? So x to the 3 halves to the minus 3 fourths times x to the 5 fourths. So in the first expression, when I multiply this out, I get what, minus 9/8. So I get x to the minus 9/8 times x to the 5 fourths. I need to add these exponents. So that becomes x to the minus 9/8 plus 5 fourths. In order to add these together, I need a common denominator. So this is x to the minus 9/8 plus 5 fourths is another way of writing it is 10/8. Okay, so negative 9/8 plus 10/8. This is x to the 1/8 power. Okay. That is my final answer, x to the 1/8. Number 11. This is 8 to the 1/2 plus 1/5, which is 8. The common denominator is going to be 10 here. So this is x to the, 8 to the 5/10 plus, and then if I convert 1/5 to, that's going to be the same as 2/10. So this is 8 to the 7/10. It would be okay if you wrote that as, the 10th root of 8 to the 7th. Either of those would be okay for that one. Okay. Moving on, page 2. Problem number 12, we're solving equations. What you want to pay attention to here is the exponent. In this one, when I look at this, I see 3 over 2. 3 is an odd number, so I'm going to solve this, but I will not have a plus or minus in my answer. The solution to this will be found by raising both sides of this equation to the 2/3 power. So when I do that, on the left, I get x plus 7 equal 8 to the 2/3. That means cube root of 8 squared. So x plus 7, cube root of 8 is 2. So that's 2 squared. X plus 7 equal 4. X equal 4 minus 7. Therefore, x is equal to -3. You can check that answer. If I plug a -3 in for x, 7 minus 3 is 4. 4 to the 3 halves, that is 8. So this is a correct answer. Number 13, I would solve this by squaring both sides of this equation, keeping in mind when I square both sides of equation, if I get multiple answers, I must check those answers. So x minus 1 squared. When I square the right side of the equation, I get 11 minus 5x. On the left side, this is x minus 1 equal 11 minus 5x. So when I do the left side, this is x squared minus 2x plus 1 equal 11 minus 5x. To set that equal to 0, I need to subtract 11 and add 5x to both sides. When I do that, I get x squared plus 3x minus 10 equals 0. I'm hoping that that will factor. It will factor if I can find two numbers that multiply to give me a -10 and add to give me a 3. Those numbers are going to be 5 and -2. So that means this is x plus 5, x minus 2 equals 0. Therefore, x is equal to -5 and +2. You must check both of these answers, okay? So let's check -5. So I'm going to go back to the original equation. -5 minus 1 equals square root of 11 minus 5, -5. So -6 equal the square root of, this is 11 plus 25, that's 36. negative 6 equals 6. That is not true. So that solution does not work. Now let's check with a 2. So 2 minus 1 equals square root of 11 minus 5 times 2. This means that 1 equals the square root of 11 minus 10 is 1. 1 equal 1. That is true. So x equal 2. That is the only solution for this problem. And you must know to go check that to figure that out. Next is simplifying. So if I go back, it said solve equations, but this one is not an equation. So this one really should just be simplify. And I think we did this before, so this is just a repeat. So let's skip this. This is a repeat so of the one that we just did. We did number 3. So let's just skip. This is probably a bad copy paste of the author of the book. Number 15. I would like to square both sides of this equation. So when I do that, I get 15 minus 2x equal x. Okay. Gather all my x's on one side and my numbers on the other. So I'm going to add 2x to both sides, and I get 15 equal 3x. Therefore, x is equal to 5. I will check that answer. Does 15 minus 2 times 5, does that equal square root of 5? This is 15 minus 10, square root of 5 equals square root of 5. Yes, that is true. So this is my solution. Number 16. I'm raised to the 4th power. Key is that's an even number. So I will have a plus or minus in my answer. So I'm going to take the 4th root of both sides of this equation. Or another way of writing it is I'm going to raise everything to the 1/4 power. So on the left, I get x plus 1 equal. I will write in big red plus or minus. Okay, you had to know to do that from this being an even root. And this is the 4th root of 81. 4th root of 81 is 3. So x plus 1 equal plus or minus 3. X is equal to negative 1 plus or minus 3. That means negative 1 plus 3, that's 2. Negative 1 minus 3, that's negative 4. Those are your two answers there. You can check these and they'll work, but you don't really need to in this case because when you recognize this being an even exponent here, you knew the knowledge of that's going to give you a plus or minus answer. So you brought the knowledge to that equation. Number 17, a power equation. Something to a power equals something to a power. This only works for you at this point of your mathematical career if I can get both sides of the equation as the same number raised to a power. So when I look at a 3 and a 9, I know that 9 is 3 squared. So I can write this as 3 squared to the x minus 1. Okay? This means that 3 to the 3x equal 3 to the 2 times x minus 1, or 3 to the 3x equal 3 to the 2x minus 2. Now I've got the same number on both sides raised to a power. That means that those exponents must be equal. So in setting those equal to each other, I find that 3x equal 2x minus 2. If I subtract 2x from both sides, I get x equals negative 2. That is the solution for that one. And we'll do a few more of those. Number 18, 1/2 to the x equal 8. Okay, now I need to look at, can I get both sides as a number raised to a power? I mean, when I look at 8, I know that's 2 cubed. And then when I look at 1/2, you've got to recognize that's 2 to the negative 1. Okay, so yes, I can write this as 2 to the negative 1 to the x equal 2 cubed. That means 2 to the negative x equal 2 cubed. Now I have the same number on both sides raised to a power. That means that negative x is equal to 3, or x is equal to negative 3. Number 19, A little bit harder with fractions, but you can handle this. My goal is both sides of the equation, powers of a number. I mean, we've worked with it long enough. You know that 27 is 3 cubed. You know that 8 is 2 cubed. So let's work with that. So I've got 2 over 3 to the 2x equal 3 cubed over 2 cubed. Okay. So that means that 2 over 3 to the 2x equal 3 halves cubed. Now I don't have the same number on both sides, but I have the reciprocal. So I can flip one of these fractions and change the exponent. Doesn't matter which one. Let's just do it on the right side. So 2/3 to the 2x is equal to, and if I flip this, this is 2/3 to the -3, okay? So I changed that 3 halves to 2/3, and I had to change the exponent. Now I've got the same number on both sides raised to a power. These exponents must be equal. So 2x equals -3, which means x equals -3 halves. Number 20, 5 to the x equal 1/25. We've been working with 125 for quite a while. You know that that is 5 cubed. So this means that 5 to the x equal 1 over 5 cubed. You can write that 5 to the x equal 5 to the -3. That means that x equal -3. 8 to the 2x equal 32 to the x plus 5. So 8, you know that 8 is 2 cubed. You know that 32 is 2 to the 5th. So if I expand all of this out, I get 2 to the 6x is equal to 2 to the 5x plus 25. Now I've got the same number on both sides raised to a power. I can set those exponents equal to each other. So 6x equal 5x plus 25. If I subtract 5x from both sides, I get that x is equal to 25. Number 22, and I think this is the last one here. 1 over 81 to the x squared equal 27 to the -8. This was a bonus on last year's quiz, but you guys can handle it. 81, you know, if you don't remember, you divide it by 3, you get 27. So I can always figure this out. That's 3 to the 4th, okay? And 27, you know, is 3 cubed. So this is 1 over 3 to the 4th x squared equal 3 cubed to the -8. I can write this as 3 to the -4 x squared equal 3 cubed to the -8, or 3 to the -4x squared equal 3 to the -24. Now I got the same number on both sides. These exponents must be equal. -4x squared equal -24. Divide both sides by -4, and I get x squared equals 6. How do I solve this? This is solving an exponential equation. This has two solutions. So x is equal to plus or minus the square root of 6. Okay, that was a little bit harder, bonus level, but it follows the same procedure. You're sort of working backwards. Instead of simplifying, you're sort of expanding some of these exponential, and you're adding negative exponents where appropriate in order to solve these power equations. So again, don't forget the review that we did in 1.5 in addition to this review for the upcoming unit test.